Why follow a needle when satellites pinpoint your exact location anywhere on Earth? For thousands of years, humanity relied on magnetic compasses, sextants, and celestial navigation to find their way across oceans and continents. But in the span of 15 years, from 1995 to 2010, a constellation of 24 satellites orbiting 12,550 miles above Earth would render an entire industry of magnetic navigation tools virtually obsolete. This is the story of how the Global Positioning System didn't just revolutionize navigation, it completely annihilated a multi-billion-dollar compass and magnetic navigation industry that had thrived for over 8 centuries. The magnetic compass industry in 1995 was a sophisticated ecosystem of manufacturers, suppliers, and specialized retailers serving everyone from weekend hikers to commercial shipping companies. Silva of Sweden dominated the outdoor recreation market with their precision orienteering compasses, while companies like Ritchie Navigation built marine compasses for everything from fishing boats to luxury yachts. Suunto had carved out the military and professional market with their high-end tactical compasses, and dozens of smaller manufacturers produced specialized instruments for surveyors, geologists, and engineers. The global compass market was worth approximately $2.8 billion annually, with magnetic declination adjustment tools, bearing compasses, and prismatic compasses representing hundreds of distinct product categories. These weren't just simple pointing devices. They were precision instruments requiring careful calibration, regular maintenance, and significant expertise to use effectively. Marine compasses alone required complex gimbal systems to remain level on rolling ships, while surveying compasses needed accuracy to within fractions of a degree for professional land measurement. The foundation for this industry's destruction had actually been laid decades earlier, but remained largely invisible to the compass manufacturers. In 1973, the United States Department of Defense began developing the Navigation Satellite Timing and Ranging System, later renamed GPS, as a military navigation aid. The first GPS satellite launched in 1978, but it would take until 1995 for the full constellation of 24 satellites to become operational. Initially, civilian access was deliberately degraded through a feature called selective availability, which introduced random errors of up to 100 meters into civilian GPS readings, making magnetic compasses still necessary for precise navigation. However, on May 2, 2000, President Bill Clinton ordered selective availability to be turned off, instantly improving civilian GPS accuracy from 100 meters to just 3 to 5 meters. This single decision marked the beginning of the end for magnetic navigation tools, though few in the compass industry recognized the existential threat they were facing. The technological superiority of GPS over magnetic compasses was so overwhelming that it represented a complete paradigm shift in navigation methodology. While a magnetic compass could only indicate direction relative to magnetic north, which varies significantly from true north depending on location and changes over time, GPS could provide exact coordinates, elevation, speed, and direction with unprecedented accuracy. GPS receivers could store waypoints, calculate distances to destinations, and provide turn-by-turn navigation instructions, capabilities that no magnetic instrument could match. By 2001, handheld GPS units like the Garmin eTrex series were available for under $100, making satellite navigation accessible to the same recreational users who had previously relied on Silva compasses costing $50 to $80. The GPS units worked regardless of weather conditions, magnetic interference, or geographical location, while magnetic compasses could be affected by nearby metal objects, electrical equipment, and magnetic declination variations that required constant adjustment and local knowledge to compensate. The marine navigation sector experienced the most dramatic disruption, as GPS fundamentally transformed how boats and ships navigated the world's oceans. Traditional marine navigation required skilled navigators who could use magnetic compasses in conjunction with charts, celestial observations, and dead reckoning to determine position. A ship's navigator needed years of training to accurately plot courses using magnetic bearings, account for compass deviation caused by the ship's metal hull, and compensate for magnetic declination changes across different geographical regions. GPS eliminated the need for virtually all of this specialized knowledge and equipment. By 2003, basic marine GPS chart plotters could display a vessel's exact position on electronic charts, automatically calculate courses to destinations, and provide constant updates on speed, heading, and time to arrival. Furuno, Raymarine, and Garmin quickly dominated the marine electronics market with integrated GPS systems that made traditional magnetic compass installations largely redundant. The United States Coast Guard began phasing out many of its radio beacon navigation aids, knowing that GPS provided superior accuracy and reliability for maritime navigation. Aviation represented another critical battlefield, where GPS systematically displaced magnetic navigation instruments that had been aviation standards for decades. Aircraft had relied on magnetic compasses, VOR radio navigation, and instrument landing systems for decades, requiring pilots to undergo extensive training in magnetic compass reading, radio navigation procedures, and complex flight planning calculations. The introduction of GPS approach procedures and area navigation capabilities fundamentally changed aviation navigation. By 2005, portable aviation GPS units like the Garmin GPS 496 could provide precise navigation information, weather data, terrain awareness, and traffic information on a single color display. Airlines began retrofitting their fleets with GPS navigation systems that reduced flight times, improved fuel efficiency, and enhanced safety margins compared to traditional magnetic compass and radio navigation methods. The Federal Aviation Administration approved GPS as a primary means of navigation for all phases of flight, including precision approaches that had previously required ground-based radio navigation aids and magnetic compass backups. The outdoor recreation market, which had been a reliable revenue source for compass manufacturers, experienced a slower but equally devastating transition to GPS technology. Silva, Sunto, and other compass manufacturers had built their reputations on precision orienteering compasses used by hikers, hunters, and outdoor enthusiasts who needed reliable navigation in remote areas. These companies had invested heavily in educating consumers about magnetic declination, compass triangulation, and map and compass navigation techniques that required significant skill and practice to master effectively. However, consumer GPS units like the Garmin eTrex and Magellan SporTrack series offered turn-by-turn navigation with electronic maps that required virtually no navigation knowledge or training to use. By 2006, these handheld GPS units had color screens, detailed topographic maps, and battery life exceeding 20 hours, making them superior to magnetic compasses for virtually all outdoor navigation applications. Geocaching, a GPS-based treasure hunting game that began in 2000, introduced millions of outdoor enthusiasts to GPS technology and demonstrated its precision and reliability in challenging terrain conditions. Professional surveying and engineering applications represented the most technically demanding segment of the magnetic navigation market, but GPS technology proved equally disruptive in these specialized fields. Land surveyors had used magnetic compasses in conjunction with theodolites, chains, and other precision instruments for centuries to measure property boundaries and create accurate maps. These professionals required compasses accurate to minutes of arc and needed extensive knowledge of local magnetic declination variations and secular magnetic changes over time. Real-time kinematic GPS systems, introduced in the late 1990s, provided centimeter-level accuracy that far exceeded what magnetic compass-based surveying could achieve. By 2004, RTK GPS systems could establish survey control points and measure property boundaries with accuracy levels that would have required weeks of traditional magnetic compass surveying to accomplish in a single day. The National Geodetic Survey began transitioning away from magnetic compass-based survey methods, and state licensing boards updated surveying standards to emphasize GPS technology over traditional magnetic navigation techniques. The compass industry's attempts to adapt and survive the GPS revolution proved largely ineffective because they failed to recognize that GPS represented a fundamental technological discontinuity rather than just another competing navigation method. Silva attempted to integrate basic GPS functionality into their compasses, creating hybrid devices that displayed GPS coordinates alongside traditional magnetic compass readings. Suunto developed electronic compasses with digital displays and GPS connectivity, marketing them as backup navigation devices for when GPS signals were unavailable. However, these adaptive strategies missed the central reality that GPS had made the core value proposition of magnetic compasses obsolete. While compass manufacturers emphasized GPS signal limitations in canyons, under heavy tree cover, or during solar storms, these scenarios represented edge cases that affected a tiny percentage of users. Meanwhile, GPS technology continued improving rapidly, with wide-area augmentation system corrections, providing 3-meter accuracy, and new satellite constellations from Russia, Europe, and China, enhancing signal availability and reliability worldwide. By 2010, the magnetic navigation industry had been reduced to a tiny fraction of its former size, serving only specialized niche markets where GPS signals were genuinely unavailable or unreliable. Military units still carried magnetic compasses as backup navigation devices, but relied primarily on GPS for operational navigation. Some mountaineers and wilderness experts maintained magnetic compass skills for extreme environments, but the vast majority of outdoor enthusiasts had transitioned entirely to GPS devices or GPS-enabled smartphones. Marine compass sales collapsed as even small recreational boats installed GPS chart plotters that provided comprehensive navigation information on integrated displays. The total global market for magnetic navigation instruments had shrunk from $2.8 billion in 1995 to approximately $180 million by 2010, representing a decline of over 90% in just 15 years. Traditional compass manufacturers either went out of business, were acquired by GPS companies, or pivoted to manufacturing other outdoor equipment entirely. The iPhone, introduced in 2007 with built-in GPS capability, delivered the final blow to consumer compass sales by putting satellite navigation capability into the pockets of hundreds of millions of users worldwide. An entire industry that had guided human navigation for 8 centuries had been rendered obsolete by satellites that could pinpoint any location on Earth with precision that magnetic compasses could never match.